let's get started in section 2.3. We're going to talk about functions, and there are several topics that we'll go through. You can see them listed here. We'll talk about the difference between a relation and a function, and then we'll talk about domain and range, and then we'll look at graphs and equations and determine whether they represent functions. We'll also look at a table and see if it represents a function. We'll talk about function notation, and then we'll finish by looking at increasing, decreasing, and constant functions. So first of all, what is a relation? A relation is any set of ordered pairs, or another way to say that is a combination of an input and an output. So anything that can be written as ordered pairs. And typically we use X for the input and Y for the output, although we don't have to. We'll see some other letters as well. So relation is a relationship between input and output. And then a function is a special type of relation where each input has exactly one output. Each input has exactly one output. You have to be real careful with this definition. Sometimes students try to put that into their own words. They change the words just a little bit and it changes the meaning. So this is a very precise statement and probably a good one just to memorize. It's a fundamental definition for this course. Okay, so we want to be able to recognize what a function is. And then we also want to talk about the domain and the range for a function or a relation. And so the domain is the set of all first components, also known as inputs, or the set of all x's, the set of all x values. And then the range is the set of all second components, or the outputs, or typically the y values. Okay, so let's go on to this first example, and let's see if we can figure out what's a function, and also if we can give the domain and the range. So let's start by determining whether each of these examples represents a function. And so again, we just want to apply the definition. For each input, there's exactly one output. So when we look at this first table, the input 5 only has one output. It doesn't matter what that output is. In this case, it happens to be 25. But what's important at the moment is that there's only one output for the number 5, for the input 5. And similarly for 6 and 7, only one output. So yes, this is a function. And we can say the same thing here in number 2. Each input has exactly one output. It doesn't matter that some of the inputs make the same output. That's not the question right now. What matters is to look at each input individually and say, okay, for 5, does it have exactly one output? 6, does it have exactly one output? 7, does it have exactly one output? In each case, the answer is yes. So again, we don't care what that output is. We're not talking about that right now. This is a function. And then in the third table, does each input have exactly one output? Well, this time the input 5 has 3 different outputs. The input 5 can make the output 6 or 7 or 8. So no, this is not a function. Sometimes I hear students say that they can look at a table, and if the input repeats, then it's not a function. If over here, if the input does not repeat, then it is a function. So that's a good, I guess, working definition or informal definition. That should work for you for the most part. But you really want to know the formal definition as well. Okay, let's go on and let's talk about domain and range. So back to the first table, the domain is the set of all x values, and so it's just 5 and 6 and 7. And the range is the set of all y values. It's 25 and 36 and 49. And so in this table, we interpret this table to mean that there are no other inputs. 1 or 2 or 3 or 4 are not inputs in this particular function. This particular function just consists of 3 points, if you would like to think of it that way. If you would like to think of those as ordered pairs, right? Each row can be written as an ordered pair. And so if you graphed this, you would have a graph with 3 discrete points on it. Okay, so the rest of this should be pretty straightforward. In number 2, the domain is 5, 6, 7, and 8. Again, this is set notation, not interval notation. We just want to write for the range 4 and 8. We don't want to write it more than once just because it appears more than once. We're not trying to say how many times the number 4 appears in the range, appears in the table. Just what are the numbers that appear as y values. Okay, so 4 and 8 for the range. And then for this last one, the domain is just the one value 5, and the range is 6, 7, and 8. Okay, so we have learned how to recognize a function from a table, and we've also learned how to state the domain and the range. In the next video, we'll go on and we'll look at a graph, and we'll be able to determine if that's a function or not, and also what is its domain and range.